Now, let me go to the second one. That is called the post hoc adjusted residual. Now, you can note it down. So, we said 20,000 above, up to 20,000 associated with 5,000, above 50,000 associated with about 20,000. That you can note it down like that. Okay.
Excuse me,
Now,
sir. So may I ask one question?
yes, sir.
So may I ask one question, please?
Yeah, please, sir, please, sir, please, sir.
Yeah, this column percentage, if at all we have row percentage, some options also. So will we
Yes.
get the same inference just like we have got for column percentage?
No, same inference, sir. But this is more comfortable, sir. Very easily
Yes.
we can combine this column with this column, because we can tell very easily, sir. That is why I prefer this one. I can explain that also, but
No problem. Yes, sir.
that will be little more confusion. But I want to avoid confusion to the maximum extent possible, sir. Right? Okay. So
Yes, sir.
already
Yes, sir. Thank you, sir.
in the expected O, you are little confused, right? I do not want to have that. Okay. I want to avoid all these things, sir. Okay. Now I'm going for post hoc adjusted residual. Right. How to use this one? Right. So now, okay. So this is also for same purpose. Okay, same purpose. Now analyze descriptive statistics, same cross tab, and then I do not want to have this cell expected. I do not have this one. Otherwise, my table will be more complex. Okay. Now I want to use this column, all these things. This is very simple. Yeah, I want to use some statistics. Yeah, I want to use some statistics. Then, okay, by using some statistics, I want to tell. Okay, then cells. Okay, cells. Each cell we have adjusted, standardized, residual, adjusted, standardized. Click that. Adjusted, standardized values. Okay. Now, let me see what is. Now, I will get this adjusted residual for each cell, because I have clicked for each cell. I have clicked for each cell because my purpose to find out which cell is associated with which cell, which column associated with one. So for each cell I want to have, that is why I used cells. Okay. So now each cell I'm getting adjusted residual 4.9, 0.1, minus. You need not worry about the minus or plus. Okay, we have to look at the value. Now this table I am presenting here. This table, it is available here. 4.9, 0.1, minus 3. Now what we have to see? Now we know that we have to see at 5% level of significance, that is 0.055% level of significance. 5% level of significance. The opposite is confidence, complementary, opposite. When we say level of significance, opposite is level of confidence. Whenever we say, whenever our significant value is less than 0.05, we will say null hypothesis is rejected at less than 0.05 level, significant level. Okay. Now, otherwise what you can tell, null hypothesis is rejected. Otherwise, no association is rejected. What do you mean by no association rejected? No rejected, which means yes, there is an association. There is an association, right? Then what we can say is there is an association at more than 95% level of confidence. We can tell like that. Instead of telling this is rejected or there is an association at less than 0.05 significant level, we can tell there is an association at more than 95% level of confidence. More than 95% level of confidence. All right. So less than 0.05, more than 95. All right. That is the meaning. Right. Very good. So okay. Now, probably some people they may know this value. Okay. Now, 95% confidence level. 95% confidence level, my Z value or T value is 1.96. 1.96, right? My confidence level should be more than 95. When it will be more than 95, my significant value is less than 0.05, right? If it decreases, my confidence level improve. When my error level decreases, my confidence level improve. When there is no error, I can say perfectly, 100% it is right, yeah. You can tell. Confidently I can tell. When error decreases, my confidence will improve, right? So, at 95% level of confidence, my T value is 1.96. Okay, so if my T value or Z value is more than 1.96, my T value, Z value, when it is more than 1.96, my confidence level is more, right? Okay, my level of significance is less. Now this adjusted residual is nothing but my confidence level or Z value, right? And my Z value is more than 1.96, then I can say there is an association. Now, there are many values, right? So, we have to choose one by one, right? See, not that Karthikeyan will sit with the Kavita also, Kumanan also will sit, but who is sitting more? That is why they are associated. Okay. So, first we have to look at the more value, then that person associated. Somebody, what will happen? Normally, see what will happen? The Karthikeyan will take Kavita every time, 95 times. 5 times the Kavita will take. Lenin also will take Kavita. 5 times. Okay, that we have to ignore, right? Okay, no. Reason this one. Sometimes the girl was coming. The girl might have asked. That is why rarely, randomly, we might have used, right? But we are worried about more. Who is more? That we will link, right? So now we will look at all these adjusted residual values. First, we will link who. Now, where more? Here I could see 6.1. Okay, which means above 50,000, associated with about 20,000. All right, same thing whatever we have stated earlier. Okay, next I'm looking at the other values, right? 3.5, 2.01, 3. Next is 4.9, 4.9. Which means right, which means above up to 20,000 associated with up to 5,000, right? So by using this also we can say which one is associated with which one. Now one thing we need to tell, one thing we need to understand, right? See, in the class, there are 4 boys, 4 girls, right? I know that Karthikeyan associate with Kavita, but we cannot say all the 4 will be associated with all 4 girls. Not necessary. Not necessary, please understand, right? We have 4 category. All the 4 category may not be associated with this one, not necessary. Even 1, even 2 associated, then you will get the chi-square value significant. Which means your chi-square will be more and the significant value will be less. When the chi-square value increases, then we will say chi-square value is significant, significantly increasing. Which means the chi-square value increasing beyond that 5% level, beyond that 26 value. Okay, that is the meaning. Chi-square value is significant. You will say, people will not tell us this one. People say my chi-square value is significant, which means my significant value is less than 0.05, right? Which means my chi-square value is more than the the table value of that 26 at 5% level of significance, right? Now this is the second one. Okay, some people what will do? This table and all good, yeah. But some people, for example, Lenin, Marx, okay, if you saw the figures, they will be attracted towards the figures. Okay, so now let me show one figure so that okay, you will be very attracted. Okay, now third one, I'm going to show the figure, right? So now, okay, now, okay, analyze. Now this is actually very big test meant for many purpose, but I'm going to use it only for this purpose, right? Now what I'm doing, I'm using another test that is called correspondence analysis. That is available under analyze, dimension reduction. If you use 16, it will be in data reduction. Let us use the dimension reduction. Then we go to the correspondence analysis. Let me use one total income row, total saving column. So here the OK is not coming because okay, we have 5 category in each, right? We know that 5 category in income also I have 5 categories, saving also I have 5 categories. Okay, I can test whether they are associated all the 5. If you want to have only no from 1 to 3 you test, that option is available. That is why defined range they are given. Defined range. Now let me test all. 1, minimum 1, maximum 5, all 5. If you want to put 1 to 3, then it will take first 3 category. If you put 2 to 5, it will take 2 to 5 alone, right? Update. Okay. Then here also I have different range. So I have put 1, I have put 5. 1, maximum 5, update. Let me say this one. Okay. Then okay, that's all. Okay. So I just put as usual row, as usual this one. I put defined range. Then let me say okay. Figure is coming. That is why it is a very big test actually. So we will get many values, right? But I think you might remember what is our chi-square value, 128.683. My significant value is 00. All right, that you might be remembering. Now, okay, now that also will come here. Now see here, my chi-square value 128. Okay, so see here, my chi-square value 128, my significant value 0.00, right? Very good. Okay. So now, okay, so many interpretation we can write, but we are not interested in that. We want to know which one is associated. Now there is a figure. Now I think you can see a figure. Now I will take this figure to PPT. Before going to this figure, now before going to the PPT, here all are in circle, but there is a color, green color, blue color. But whenever we put it in thesis, we will be printing in a black and white, which means color will not be visible. So it is better to change the design. So how to change the design? Already I have told you. If at all you want to change the color, if at all you want to change the design, you click this one. Then you will get the chart editor. Chart editor. There is a chart editor. In the chart editor, okay. So now let me change this one, right? Okay. Now let me change this total income. Here there is a circle. I do not want to have circle. Let me have a square. Let me have a square one. Now I want to have the size small. Yeah, I'm not able to see. Let me put 8. Then size will increase. Then fill also. Let me put some colorful red color. Colorful red color. If I can apply, then okay. So size is increased, color is changed. So next, if you want to change, here design. Let us have circle itself, because now let us change the size to 8. So now let us make it as green. Green, right? Green. Apply. Okay. Then then it will change. Then if you change it here, the colors will come. Now you can copy and paste. You can copy and paste, so that you can do. Now let me go to the PPT. Now let me go to the PPT. Same thing I have copied. Same thing I have copied. Okay. Same thing. But probably I might have used a different color. So that is the only change I might have done. Okay. So now green, orange we have put. Okay. Now see, now what will happen? That Kartikeyan is associated with Kavita. What does it mean? Kartikeyan sitting along with Kavita. All right. Kartikeyan associated with Kavita. What is the meaning? Kartikeyan sitting closer with Kavita. Now, whoever sit closer, they are associated. Simple. Now you can see up to 5,000 saving. Saving is this color diagram, right? Okay. So now income is 20,000. So this and this associated. All right. Now, as we have stated, these two are separate. They will go in a separate place and they will sit. Okay, such kind of people. Okay. So now this 5 to 50,000 and about 20,000, right? So like this, we can say these two are associated. These two are associated. These two are associated. Like that we can say. But you have to tell when they are very close. Then they are very closely associated. When the distance is more, association may be there, but closeness will not be there. Now, some people, they are closely associated. What they will do? For example, Kartikeyan closely associated with Kavita, probably he will sit on the thigh of that Kavita. So such a close position he will sit. Okay. So now that is what we can see. That is what we can see. Right. Very good. Okay. So now this is with respect to post-hoc test to find out which category is associated with which another category of another variable. Right. The post-hoc is over. We have identified that Kartikeyan associated with Kavidaya. Very good. Now we have one more question. Now, for example, that Kavita father has noticed that Kavita is going along with the Kartikeyan. We have seen Now he is going to the Kavita's father. Hey Sanmugam, hey Sanmugam, hey, hey. Yes, tell Ra, tell. I've seen your girl with that boy. Yeah. So, yes, I have seen with my own eyes. I have seen. Now, okay, then he has informed him. Now, Kavita's father, Sanmugam, what is he doing? He is trying to arrange marriage for the Kavita with some other boy because he does not like that Kartikeyan. He is looking for some other boy after hearing the news from that Govindasamy. Okay, he is arranging, he is seeing some boys. Now Govindasamy is coming to Sanmugam. Hey, Govindasamy, hey, Sanmugam, don't arrange any other boy. Don't arrange any other boy, da, because your girl is so much associated with Kartikeyan. If you break, probably she might suicide. Why? Because the association is very, very, very strong. Okay, so we need to find out the strength of association. We have to find out we say that first associated, which one is associated. Now we are going to find out the strength of association. Now, to find out the strength of association, we are going to use I and Kramer's V. This is a statistics. This is a statistics, right? So now, how to use? Now we will go to the I-square, analyze descriptive statistics, then go to crosstab. Now the cells and all we will remove, otherwise all will come. Okay, adjusted residual removed. Okay, now I want to have some statistics. So I am going to the statistics. If I want to have each cell, then I have to go to cell. If I want to have total statistics, I have to go to the statistics. In the statistics, we have many statistics, but we will use this pi and Kramer's pi. Normally, pi is used for 2 by 2 matrix. Kramer's we used for other cases. Okay, so now we will use, we will click that. Okay, now pi and Kramer's v. Pi and Kramer's. Now I got a result. What is the result? Pi is 0.483. This is 0.241 Kramer's v. This is the value, right? Some people, they are given a rule of thumb. What is the rule of thumb? The same table I am going to take there. Okay, same 0.483, 0.241, same 0.00. Right. Now, the rule of thumb. According to the pi, value of 0.1 is considered as small effect. Smallest, the association is less. 0.3 association is medium. 0.5 association is large. Here, look at the pi. 0.48, approximately equivalent to 5. So we can say that the strength of association is large. There is the effect size, strength is high. Okay, so this is with respect to pi. Now Kramer's V. Now in the Kramer's V formula, they have used the degrees of freedom. So we have to judge the value based on the degrees of freedom. Okay, degrees of freedom means minimum of rho minus 1, comma column minus 1, whichever is less. Here, we have 5 row, we have 5 column. So, 5 minus 1, 4, 5 minus 1, 4. So, minimum of 4, 4, which is 4. So, our degrees of freedom is 4. Now, let us go to the 4. If Cramer's is 0.05, then it is small. If the Cramer's is 0.15, it is medium. If the Cramer's is 0.25, it is large. Now, my Cramer's is 0.241, which is near to 0.25, which means there is a large effect. So now we can say not only there is a significant association, strength between each category, the strength of association is very, very strong. So we can say that they are most likely happen. Okay, it is not weak association. It is a very, very strong association. Very, very strong association, which means Kavita is loving Karthikeyan very, very strongly. You cannot do anything. If you do anything like Kokila, she will say the father is a bad father. Yes, he will file a case against the father. Okay, very good. Okay, okay. Now, I thought I will have more time. Okay, I have put one more exercise also, but now no time. No time. So let me go to the other thing. Now, we should not use. Okay, now this I will come later. Okay, so now, okay, okay. So now we have talked about the expected value, right? Right. Observed is actual, whatever frequency appears. How many people are there? Okay. What is expected? How it is calculated? Now, let me take a small example. Okay. For the sake of simplicity, I am taking, let us assume that I am assuming, yeah, I am taking 2 category in each. Okay. In saving, I got up to 5,000 and 5,000 to 10,000. In income, I got up to 20,000, 20,000 to 30,000. Only 2 by 2 matrix I have to. Simple, for the sake of simplicity. Let us assume that I have collected from 200 people. In that 200, 150 people total, right? In that 200, 150 people are in this income category. 50 people are in this income category. Very good. Now, out of these 200 people, 100 people are in this saving category. 100 people are in this saving category. Right. I want to know what is the expected value for each of these 4 cells. That is what my purpose. Expected value for each cell. Okay. Now, how to find out expected? Very simple. Let me tell you. Out of 250, 150 people are in this income. Okay, which means 78% of the people. Okay. Out of 200, 150. Then, here what should come? Out of 200, it is 150. Then out of 100, it should be 75. Yes or no? When it is 150 out of 200, then out of 100, it should be 75. So, 150 out of 200, then what is out of 100, which is equal to 75. Okay. Now, for expected frequency, I have written a formula also. In the book, they will write a formula. What is the formula? Row total into column total divided by total overall total they will write. Now, what is row total? 150. What is column total? 100 divided by overall total 200. So 150, this is simple meaning of simple logic. People will give formula, that formula and are not necessary. And it is 150 out of 200, what is out of 100? That's all over. This is the expected value. This is the expected. Now we have stated, no, this is for 2 by 2. This is for double this one, two variable situation, right? If it is only one, then we will put a total divided by how many frequency. So 4 girls divided by 4, so 25 we have. Right. So now I hope you might have understood the expected value.